Okay, this is it. Last video. Let's wrap this this up here. It's the same sheet that looks like the other two, except we are not doing substitution. Now we're looking at elimination. Elimination is my absolute favorite because it is so quick and so easy. So let's go. So keeping in mind, the focus of this standard is special cases. Special cases is when the variables cancel. So I want you to, at the top of your page, I had you rated at the bottom of the last section. So when your variables, meaning your x's and your y's, cancel, ... That's what I'm looking for. When my variables cancel out in these problems, something's up. I am not going to give an 8,5 answer. I'm either going to write the words no solution or infinitely many. That's what I'm going to write. Okay? It's going to be one of those two. It will be no solution if what's left is false. It will be infinitely many if what's left is true. And by that I mean like 4 equals 4. Yeah, that's true. Okay? False means 3 equals 4. That's not true. Okay, so let's find this. So if you remember elimination, I have to get it in standard form, meaning everything needs to line up. And by line up, I mean, are your x's above each other? Are your y's above each other? Is your equal sign next? And is your constant last? That's what I mean by line up. And these are good. They're ready to go. They are so ready that all I literally have to do, it even looks like this line is drawn. All I have to do is draw this line. And I'm looking for the same variable, but one positive, one negative. And it's done. It's ready for us. Let's get rid of those y's. After I get rid of those y's, I then have to go ahead and add vertically what I have left. So I have one x here plus another x here. That gives me 2 x's. And I have 5 here plus 1, which gives me 6. Oh my gosh, you guys, I love elimination. Look how quickly I found max value. Did the variables cancel? These did, but these didn't. So let's take a look. Now I want you to be careful because it's funny because in elimination, that's supposed to happen. The variables are supposed to cancel, but one of them. Let's take a look at what this means though. So now that I have a 3 here, I know my answer is going to be 3 comma something. I won't know what that y value is until I go back up into one of these equations and put x as 3 and solve for y. So if I put 3 here plus y equals 5, I don't have to solve fancy equations. What number do I need to add to 3 to get 5? I have to add 2 to it. And here's how you would get that, right? Don't always just use, like, there's your y value. So if I were to graph these two equations, they would meet at the point 3, 2, which means how many solutions do they have? 1 solution. Okay? Easy. Easy peasy. We've done those all day, right? Now, let's take a look at this next example, though. And as soon as you look at it, you're probably like, wait a second. That looks almost identical. Everything kind of looks the same, except if you look a little closer, you'll see that the 6 x's are already set up to cancel, but so are the y's. I have a positive and a negative 4y, a positive and negative 6, and a positive and negative 12. This is like a dream come true problem because you literally have 0 work to show. You don't have to show any work except write your answer. Here's how I know what the answer is going to be. Because over here, when I went to go cancel the y's, but I still had x's left, here, when I go to cancel the y's, not only do the y's cancel, but the x's cancel also. So when variables cancel, meaning they, in this case, we want to put when both variables cancel, I should put that over here, you know something's up because I have 0x, 0y. What's left on this left-hand side of the equal sign? A big fat nothing. There's nothing left. Everything wiped out, okay? And what's positive 12 plus negative 12? 0. So my variables are gone. There's no variables anywhere around, so I know there's not going to be a solution. Now I just have to look to see if this is true or false. Does 0 equal 0? Yeah, it does. All day, every day. It's true. And if you remember back to what does a true statement mean, it means that I have an infinite number of solutions. Okay, infinitely many, infinite solutions. And I'm going to refer back to this again. It means that if I were to graph these two lines, one line will be right on top of the other. And if the whole purpose of systems is where do these two lines meet, they meet everywhere. They meet everywhere, here, 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 and here. So I didn't even have to show any work for this problem. If you try to do this as a substitution, oh my gosh, you're gonna do so much work. You guys, I'm trying to show you ahead of time how quickly and easily you can tell if there's going to be a solution. And now that I know this, let's go back to this problem. Because if only one variable canceled and I'm still left with a variable, I know there's going to be one solution. I know it without even having to finish the problem because there's an x, there's going to be an x to solve for. So if I asked you to just tell me how many solutions, you would just say 1. I won't care. I wouldn't even care about the 3 and the 2. There would just be one solution, okay? So let's take a look at number 11. So number 11 says, oh, there's nothing like set up for you even. Okay, I have my x's above my x, my y's above my y's, and my constants, except this one's not ready. And by ready, I mean it's already ready to be canceled, one of the variables. But these y's look pretty darn close. If one of them was a negative and the other one was a positive, doesn't matter which one, then I'd be ready to go. So I have to make one of them a negative. How do I do that? Do you remember what we did in the the elimination video? I have to pick one of these two equations. I don't care which one. And I just have to multiply it by a -1 because multiplying by a -1 changes the sign of everything. So I'm going to have this here. This is going to change this -x to a +x. It's going to change this +2 to a -2y. And don't forget, a lot of kids forget this, it's going to change the -10 to a +10. I literally just took the opposite of everything. That's what distributing a -1 does, you guys. Now, I kind of want this equation to be right underneath it so I can line it up and stuff. So I'm just going to bring this equation down, making sure everything stays lined up. And here's my 20. Now, I'm ready. I see that I have the whole purpose of this lesson is elimination. I don't know if you noticed it, but that's your point is to eliminate a variable. And so look, as soon as I draw that line, I'm done. I technically, unless I ask you for what is the actual solution, I don't have to show any more work. Because if I said, hey guys, how many solutions does this system have? You could stop right here, skip all this work, and go all the way down to it's got one solution. How do I know it's got one solution? Because both variables did not cancel. If I were to finish this problem and say 1x plus 4x is 5x, 10 plus 20 is 30. Oh, there's an x, there's an answer. Got it? If there's an x, there's an answer. There's going to be an xy answer here. I know that these two lines, without even finishing, will meet at a point on the line, at one point. Okay, if the question was how many solutions, you could stop. On the test, though, if it says now solve it, then you gotta finish it. You don't have a choice. But elimination is easy. X is 6. Great. I just found out that X is 6. I'll have my Y value real quick as soon as I pick one of these equations and put in 6 right there. So let's just pick this top one. Well, let's put an X here. So let's do 4 times 6 plus 2y is equal to 20. 24 plus 2y is equal to 20. My goal is that you are flying through these equations. You subtract 24 because you need that 24 over here. Minus 24. Okay, now, here's what I need you guys to know. These are like terms. When we did this other stuff, one had a y, you couldn't combine them. You can combine these, and you should. One's a positive, one's a negative. Subtract. You get -4. Divide both sides by 2. After all that fancy equation solving, I find out that my y value is -2, so I put it in the y spot. That's my answer. So the purpose of this lesson is to show you if you, let me zoom out, sorry, not in. If I said, how many solutions does this system have? As soon as you got right here, you could have stopped and you could have written one solution. But if I say, now solve it means, okay, sorry guys, you got to keep going. Get me the whole answer. Okay? All right, we have one more problem and then we are done. And a couple things is going to happen here. First thing, you're looking at it and you're saying, well, it's all out of whack because like they're not lined up. There's two terms on the left. So you have to line your terms up first. So let's do that. This first equation looks okay. I have my x term, my y term. So I'm going to save a little bit of room right here. But let's put my x term here. I'm just actually recopying this top equation. Now, if this y term, it could stay where it's at on the left, but if this x term were to get over here, we'd be good, right? So it's kind of like I just need to get this whole x term in front. So let's take this -2y and put it here. The 4 is okay, but I have to add 7x to both sides. And now that I got it here, I have that. Okay. So as I'm looking at this, if my question is to you, how many solutions does this system have? You're looking at it and you know something looks weird because they're not ready to cancel yet because they have to be different signs, remember? These are both positive, these are both negative. So I'm going to have to do this fancy thing where I pick one and multiply it by a negative, okay? Which means it's like magic wand. It's going to go change, change, change. It's going to change everything to the opposite. So below this equation, I'm going to write this new one. This is going to give me a -7x. This becomes a +2y. This 3 becomes a -3. I don't need this equation anymore. And now it's ready to go ahead and combine. And remember, if you remember what I said over all the course of all these videos, you can use this shortcut because when the 7s go to cancel, oh, the 2's also, the y's also cancel, which leaves me with nothing. There's nothing over here, just like this example we did a minute ago when there was nothing over here, except look, the 12's canceled also and left me with a true statement. Does the 4 and the -3 cancel? No. 4 plus -3 is 1. Okay? Is 0 equal 1? No, never. Oh, so that means I don't have a true statement. I have a false statement. And if I have a false statement, false means no solution. So will these two lines, if I graph them on a graph, ever meet anywhere? No, they won't. So you're going to write the word no solutions. Okay, you guys? That's it. And here's the important thing to remember for elimination. Both variables must cancel for something kooky to happen. Both. Okay? Sorry, this paper. Both variables must cancel. As soon as you see both variables canceling, all you have to do, you know where there's not going to be any one solution. There might be none and there might be infinitely many. I'll do the same thing as I did at the bottom of the other notes. You have to figure out if it's true or false. A true means that's you're going to write the words all numbers or infinitely, I think is infinitely many is what you see mostly. And false, you're literally just going to write no solution. You could put SOL, no solution. Okay, these are special cases, and it's getting you more practice with solving systems, except this time the practice work you do is not going to be all these answers. There's going to be these and these sprinkled in there. You just have to find them.